Hey, ChemStars, this is Mrs. Vandewally bringing you the very first edition of the ChemStar video where you are the star. And so I know that we've already talked about this. I want to start at the beginning of the notes and kind of review what we've done. We had demo day already, and we love demo day. Demo day is where you blow things up, right? And we were trying to show you how those different demos apply to the definition of chemistry. So the rest of the chapter really talks about all these things in the definition. So what is chemistry? Chemistry, again, is the study of the composition, the structure, and the properties of matter, and the processes that matter undergoes, and the energy changes that accompany these processes. So we're going to kind of revisit this edition or this definition again, and we're going to see something about composition and structure. How are things put together? We're going to look at some properties of matter and how they're arranged. The processes that these matters undergo. It's not just looking at the stuff, but what does that stuff do? And again, how does the matter undergo changes? Well, you need energy involved to have these. So these are topics that we're going to talk about. And so let's turn to the next section, which is, I think, 1.2.1. So hang on. So here we are. We are in section 1.2.1, matter and its properties. So keep in mind, what is matter? Matter is anything that has mass and take up space. So what is matter? Well, matter can be defined as atoms or elements or compounds. Those are all have mass and take up space. So we are going to define atoms, elements, and compounds, and there's our key vocabulary. So what's an atom? Well, that's a good question. Atoms are the building blocks of matter. An atom is the smallest unit of an element that maintains its chemical identity of that element. So let's see how this picture kind of helps us out here. It says atoms as building blocks. This is considered an element. Why? Because they're made up of atoms, see that? But these are all the exact same atoms. So diamonds are made up of all carbon atoms. And it's how they're arranged is what gives the diamonds its qualities. But over here, this is an element, or excuse me, this is a compound. How do I know that? Because it's made up of different atoms. It's made up of hydrogen atoms, those are the blue ones, carbon atoms are the green ones, and oxygens are the red ones. So atoms make up anything that has mass and takes up space. Okay, so let's kind of see, talk about elements and compounds a little bit. So element is a pure substance that cannot be broken down into a simpler, stable substance and is made up of what? This is important, is made up of one kind of element. So let's highlight that. It's made up of only one type of element. That's what makes an element. They're all made up of the same stuff. So again, which is the element from the example above? Hopefully you got diamonds. Why? They are all the same element. They're all carbon. Now go back from demo day. Why don't you go back a couple pages? So let's think of the very first one we did when we burnt the magnesium, right? That is an element. Your magnesium is an element. And how would that look like we have up here? How does magnesium look? And I just have three of the exact same atoms, kind of like loosely put together. There's a little bit difference on how the carbon atoms in a diamond are arranged versus magnesium atoms. Let's not get into the hows and the whys and why they're different. Maybe we can talk about that a little bit more later on this chapter, but for right now, just go with that. Put three little circles, and I would even put little bonds on them, or little pegs, if you will. So just do it like that and we're good, okay? So what about a compound? What is a compound? Compound is a substance that can be broken down into simple, stable substances. You can still break it down. Each compound is made up from atoms of what? Oh, this is important. Two or more different elements that are chemically bonded. That's key. So what example from above is a compound? Was it diamond? No, they're all the same carbon. Is it sucrose, table sugar? Yes, it is. How do I know that? Because they're made up of three different elements. Okay, so sucrose has a carbon, hydrogen, oxygen chemically bonded together. So what about demo day? Why don't you go back and talk about that can again, all right? Do you remember what we put in that can? We put methane in that can. And what's the formula for methane? It is CH4, all right? That's a compound. How do I know? There's one carbon and four hydrogens. And what does that look like using a particle diagram here? There it is. I made the carbon black and the hydrogen kind of a, I don't know, brownish color. I could have put other ones in there. Most of what we had in that demo day were compounds. I could have used the ethanol as an example, and that's C2H5OH, and that would be also a compound, but that's not as easy to draw in little circles, so I just try to keep it simple if you get it. So that would be your CH4. And if you go back and look at demo day, there is another substance, if you will, that we used a lot of, and that was oxygen. Remember, we needed to burn magnesium with the oxygen in the air. The ethanol reacted with the oxygen in the canister. So how does that fit in? The problem is that it doesn't. All right, O2, is it an element or is it a compound? Well, go back. All right, an element is a pure substance that cannot be broken down into simple, stable substances that cannot be broken down, all right? The problem is, what's O2? Is it an element or a compound? It's an element for sure, but it's a special name. It's called a diatomic element, all right? It's a pure substance that can be made up two of the same atoms chemically bonded. Why is it not a perfect fit for just a plain old element? Because you can break down O2 into O's, all right, an O and an O, all right? So it doesn't fit the pure definition of that where it says it cannot be broken down. You can break down these diatomic elements, okay? So that's why you give it a little special name there, okay? All right, well, I believe that concludes section 1.2.1. So I will leave you with this thought. Don't wait to be great. So we'll see you next time. Bye-bye.